Okay, so 3.4, we already did graphing linear systems in 2 variables with 2 equations. We're just adding a third variable and a third equation. So however many variables you have, that's how many equations you need. So you could solve a system with 5 variables, but you would need 5 equations. Okay, so we've got a couple of key terms, linear equation in 3 variables. All right, so this is our linear equation. And it's in the form with 3 variables, so it's ax plus by. So x is a variable, y is a variable, z is a variable. So before we had ax plus by equals c, but we're throwing in this third variable, z, and this is where a, b, and c do not equal 0. As a general definition, we have to say they don't equal 0 because if one of these variables, a, for example, if a was 0, we would only have 2 variables. We would only have y and z because x wouldn't exist. It would be like 0x, which is 0. So we need to say that a, b, and c don't equal 0 just as our definition. At some point in the system, and we'll talk about system in just a second, but at some point in the system, you might find that there's only 2 variables and you have 3 equations, but within the system, you'll have 3 different variables and 3 equations. Okay, so the second term, system of 3 linear equations. So that's 3 equations, each with 3 variables, and within the 3 equations, the 3 variables are the same. So x, y, and z in all 3 equations. So 3 equations, each with up to 3 variables. So for example, an example of a system of 3 linear equations would be something like the first equation could be 2x plus y minus z equals 5. You would have a second equation with the same 3 variables. So 3x minus 2y plus z equals 16. And then you would have a third equation with x, y, and z, like 4x plus 3y minus 5z equals 3. Okay, and then the last term that we have is an ordered triple. So we have been working with ordered pairs. So like here's your x-axis, here's your y-axis. An ordered pair would be like x and y. Well, now since we have 3 linear equations and 3 variables, we've got 3 axes. So like here's our z-axis, here's our y-axis, here's our x-axis, and our ordered triple would be x, y, z. Okay. Yeah, this is a little bit harder, but it's really just 1 or 2 extra steps. Okay, so it's a little bit more complex, but it's not all that different. It's just adding 1 more step to what we've done before. So an ordered triplet is x, y, and z, whose coordinates make each equation true. Okay, so with equations with 3 variables, the graphs of these look, and you see this on your note sheet too, but it's a little easier to see here because there's color. So with this first one, exactly 1 solution this is the only point where the blue plane, the green plane, and the red plane all intersect together. So again, with this system, all three equations have to be true. So this is the only point where all three equations intersect. With the second one, along this line, the blue plane, the green plane, and the green plane, they share infinitely many solutions because they share a line. And with a line, there are infinitely many points that make the line. Okay, so that's why this has infinitely many solutions, because the blue and the green and the red all share a line. If you have no solution, okay, so if you look here, the blue and the green, see how they share infinitely many points? And the blue and the red, infinitely many. The red and the green, infinitely many. But there is no point where the red, the blue, and the green all intersect. Okay, so that's why that first one, the one that looks like a triangle, is no solution, because there's no point where the red, the blue, and the green all share a common point, or a common line, or a common plane. The second one, same thing, red and green, infinitely many solutions, blue and red, infinitely many solutions, but blue and green, no solutions. Okay, if blue and green have no solutions, then the whole system has no solution, because if blue and green never intersect, there's no common point in all three, for all three equations. So like the red would be the first equation, green would be second, blue would be third. Even though 1 and 2 have infinitely many solutions, and 1 and 3 have infinitely many solutions, 2 and 3 have nothing. Okay, so 2 and 3 are no solution, that means the whole system is no solution. And then with the third one, all three planes are parallel. None of them ever intersect with the other one, so the whole system is no solution. Okay, if you look at this cutout, like the key concept cutout, these are the steps that we're going to follow for solving linear system with 3 variables. So our first step, and we'll do this every time whether we know that there's infinitely many or no solutions or one single solution, we want to rewrite the linear system in 3 variables as a linear system in 2 variables. It's going to be way easier to solve 2 variables than it is to solve 3 variables. So our first step is to get rid of one of those variables. And we're going to do that using the elimination method. And then our next step is to solve for those 2 variables. So now we have 2 equations and 2 variables. So we can use either substitution or elimination, doesn't matter which one. And then we're going to work backwards and substitute those values in to our previous equations. If at any point when we're solving for our variables we get something false, like 0 equals 1, that means there's no solution. Okay, so it doesn't matter if we only find it within 2 equations. Like if we look back here, and let's say we're working with equation 2 and equation 3, and we get no solution. If we get it for any 2 equations, the whole system is no solution. Okay? But if we get something that says 0 equals 0, we have to make sure that's true with all 3 equations. Okay, so normally, like if we only had 2 variables, and we got a true statement like this, 0 equals 0, we could stop and say, okay, this is true. 0 is always going to equal 0. So this has infinitely many solutions. But when we're working with 3 variables, we have to make sure this is true for all 3 equations involved. Okay, so here, it's true here, infinitely many solutions, and it's true here, infinitely many solutions. But if we compare equation 2 and 3, we would not get that same thing. Okay, so if you get a true statement like that, you're not done. You have to prove it's true for all 3 of those equations. We're using the elimination method. So we need to pick 2 pairs of equations. Okay, we're going to eliminate a variable. We're going to eliminate the same variable in both pairs of equations. Okay, so first pair, which 2 equations do you want to use?
Last 2.
Okay. The last 2.
My answer is here. Huh?
Bottom two.
Bottom two.
Oh, and
Someone for listening.
and what else? What other ones? Okay, that's one pair. Let's start.
Oh, there's two pairs.
We need two pairs. So our first pair, negative x plus 5y plus 12z equals 73. X plus 3y minus 2z equals 1. Okay, that's our first pair of equations.
Oh my god.
We're going to eliminate x. Rewrite your equation. 8y plus 10z equals 74. Now we have one equation with two variables. We need another equation with those same two variables. So we're going to pick another pair, and we're going to do that, pick that pair, and then we're going to eliminate x.
We should do equation 1 and 3.
Okay. 1 and 3?
Why not 1 and 2?
Yeah, let's
Negative.
do 1 and 2. Yes, because it's negative. You can do, it doesn't matter. You can do any pair,
Wrong.
but you can do any pair. It doesn't matter. But if you do 1 and 2, you don't have to work with negative signs. All right.
Smart.
So let's rewrite that. 3x minus 2y plus 4z. Do something when you're writing to distinguish between 2's and z's. Okay?
I'm like the same thing.
Do something, whether you write your 2's like this or your z's like that, but do something to distinguish between 2's and z's for yourself and for me when I'm grading it on your test. So you don't end up adding 42 instead of 4z. Okay, so 3x minus 2y plus 4z equals 20. And negative x plus 5y plus 12z equals 73. Okay, now we want to eliminate x. What do we do? Jeremy?
Multiply the equation number 2 by 3.
Okay, so now let's rewrite it. So I'm going to rewrite both equations together so I can keep them together. 3x minus 2y plus 4z equals 20. And negative 3x plus 15y plus 36z equals, let's see, 25, 219. Okay, now I'm going to add these together. Cancel out my x's. That I have to focus on my x's because I eliminated my x's in the first one. So I want to keep the same two variables in these two equations, which is y and z. Okay, so then I get 13y plus 40z equals 239. I'm going to bring this equation. I like to have my equations top and bottom so that I can see them lined up easily. Right, now I'm back to like what we did in the first couple lessons of this chapter. I have two equations with two variables. So your first step is to eliminate one variable and do that with two pairs of equations. Then you're left with just two equations, two variables. So now what do you want to do?
Multiply the first.
By
4.
What?
But it's just 4.
Not 4. We multiply by 4, we get 4.
Negative 4.
Negative 4. Oh, you. So yeah, pay attention to your positive and negative signs. Otherwise, you're going to make adding or multiplying mistakes. So keep in mind that you want to eliminate something. Okay, so I'm going to rewrite these. 8y times negative 4 is negative 32y minus 40z equals negative 296. And then my second one is 13y plus 40z equals 239. Add these two together. My z's cancel out. Negative 40z plus 40z is 0z. So negative 32y plus 13, negative 19y equals negative 57. Isolate y. Solve for y. So divide both sides by negative 19. And we get y equals 3. Okay. Okay, so we've got our y. We solved for y. Now let's pick one of these equations. Doesn't matter which one. This one we could use. We can use this one if we wanted.
You don't use the original equation?
Well, you can't use the original equation quite yet because you only have one variable to solve for. All of your original equations, you have 3 variables. Okay, so you could go back and like get rid of y and then use 2 equations with that. I think that's a lot of extra work. You don't have to do that, but just don't make mistakes rewriting your equations. Okay, and always check your answers at the end. Okay, so we can use 13y plus 40z equals 239. We can use negative 32y minus 40z equals negative 296, or you can use 8y plus 10z equals 74. What do you guys want to do? That's probably the easiest.
What is y?
Okay, so we have y. Let's solve for z. Okay, so we already have our y value. So let's use this equation just because it looks the simplest out of all of the other ones. There's not negative signs and the numbers are still kind of small and we have a 10 in there, so it makes it a little bit easier. So 8y, which we just said our y is 3, plus 10z equals 74. 24 plus 10z equals 74. Subtract 24 from both sides, we get 10z equals 50. Solve for z by dividing both sides by 10, and we get z equals 5. Okay, that's our second variable that we just solved for. So now we have a y and we have a z.
Does it matter what equation you pick?
No. So, no, it doesn't matter. So it doesn't matter which equation you pick. As soon as you hit y, you want to pick an equation that has 2 variables, y and something else. So we picked an equation that had y and z to solve for z. Now we have y and z. So we can go up to here, one of these original equations. We have a y, we have a z. Let's solve for x. And what do you guys want to use? The last one. I would probably use the last one. Okay, so x, we don't know x.
Yeah.
Okay, we don't know x yet, but we know y, which is 3. We know z, which is 5. So x plus 3y minus 2z should equal 1. X plus 9 minus 10, that equals 1. Add 1 to both sides, and we get x equals 2. Okay, so our solution for this, our ordered triple, oops. Would be, 2, 3, 5.
You just solve that for 3 numbers.
Yep. Not done. Okay, so we have our solution, our order triple, 2, 3, 5. We need to double check this because we used a lot of new equations. We didn't just stick to the original ones. So let's double check this. Our first, and this is quick. You guys can do this quickly on your calculator to double check. Alright, so girls, the first equation, 3 times x, which is 2, minus 2 times y, which is 3, plus 4 times 5, that should give you 20. 6 minus 6 plus 20 equals 20. Okay, that works. Second one, negative x, which is 2, plus 5 times y, plus 12 times z equals 73. Negative 2 plus 15, that's 13, 13 plus 12 times 5 is 60. 13 plus 60 is 73. That's good. Third equation, 2 plus 3y minus 2z. That should equal 1. 2 plus 9, that's 11, minus 10 is 1. That's it. That's it. That took 1 minute to double check. You can do it in your calculator, but always double check. Okay, so example 2, solve 3 variable system. This one has no solution. It tells you there's no solution, but on the test or quizzes, it will tell you there's no solution. Okay, so our first step is to eliminate a variable. What do we want to eliminate? The first and second. Okay, what variable should we eliminate for x? Everybody always wants to eliminate x because it's first. But look at our y. Okay, let's eliminate our y. Okay, so what do you want to use? This one and this one first? Okay, 1 and 3 first. So 2x plus 4y plus 10z equals 14. 3x minus 4y minus 3z equals 15. Add these together to get our new equation. Girls, please stop talking. 5x, y's are gone, minus 7z equals 29. That's one equation with 2 variables. We need one more equation with 2 variables. We're going to eliminate y. What 2 equations should we use to eliminate y? Okay, 1 and 2. We can do 1 and 2. I probably personally would do 2 and 3 because then I have positive and negative. But you can do. Let's do 1 and 2. Question. Ooh. Positive 7z. All right. So okay, it doesn't matter if we use 1 and 2 or 2 and 3. I probably would use 2 and 3, but let's do 1 and 2 just because now I'm seeing a pattern here. So let's do 1 and 2 to eliminate y again because that's the one we eliminated in the first equation. We're always going to eliminate the same variable. So 2x plus 4y plus 10z equals 14. And then x plus 2y plus 5z equals negative 4. Okay, now to eliminate y, we need to multiply this bottom equation by negative 2. So I'm going to rewrite it again. I like to rewrite equations. Okay, and then negative 2x minus 4y minus 10z equals 8. Now they all eliminate. That eliminates, that eliminates, that eliminates, and we end up with 0 equals 22. That's not true. That is not true.
Yes, it is.
0 will never equal 22. Okay, so if ever you get a false statement, you don't have to get a false statement 3 times, but if ever you get a false statement, then those 2 equations have nothing in common, which means the whole system does not share one single point. So, no solution. Okay, this is part 1. We'll do part 2 on Wednesday during class.